Good morning, children. Children, today we will be studying gametogenesis. Gametogenesis refers to the production of gametes in the body, and you will be studying male and female gametogenesis today. Right, children? This is the heading. So, I am just moving the heading slightly forward. You can see that the heading here is spermatogenesis. That means, first of all, the whole flow chart that you are seeing on the screen, this will be explaining how sperm or spermatozoa is formed inside the male body. First of all, before learning this whole flow chart, what you have to see is that male spermatogenesis is actually divided into two sub processes. Sub processes means the first one here is spermatocytogenesis. So this will be the stage of spermatocyte where spermatocytes are formed. So this is spermatocytogenesis, and second one would be spermiogenesis. If you can see it here, spermiogenesis. So these two terms are different terms, and the whole spermatogenesis is divided into these two subheadings. The first one here is spermatocytogenesis, and second one is spermiogenesis. Right, children? Now you can proceed further with the flow chart here. If you can see that the whole flow chart is again, these two are the processes, that's okay, but you can see that the common thing that which will be following in spermatogenesis and oogenesis are the three phases. The whole spermatogenesis process is completed under three phases. One phase is characterized by multiplication, second phase is characterized by growth, and the third phase is characterized by the maturation of the developing spermatozoa. Right, children? So must understand these two things. They are quite confusing. You have to understand that multiplication phase, growth phase, and maturation phase, these three phases are common while learning about spermatogenesis and oogenesis. But apart from this, when you are explaining spermatogenesis here, at that time you have to take care that spermatogenesis is subdivided into a stage up till the formation of spermatocyte and a stage up till the formation of sperm. So depending upon what structure is being formed, it is spermatocytogenesis and spermiogenesis. Right, children? Let us proceed now. I hope that the flow chart is quite clear to you. What is happening here? You see that we always start the spermatogenesis or oogenesis, any of the gametogenesis flow chart is always started by PGC. PGC is primordial germ cell. That means the cell which is present in the germinal epithelium. I have already explained to you what is germinal epithelium, right? So primordial germ cell is a cell that proliferates out of the germinal epithelium. So you are going to start with the flow chart with this particular cell, right? Then what you have to notice is within these circles, I have mentioned the chromosome number. You can see that the parent cell was diploid, then the offsprings, the two cells formed were again diploid, then further two formed four cells. So these are also diploid. So every time the parental chromosome number is maintained in the offspring. That means which cell division is going on here? Mitosis. Right, children? Simply you will say mitosis. So this particular phase, if you can see the first black bracket, this is characterizing the multiplication phase where one primordial germ cell converted into four. So we are talking about so many primordial germ cells that have been undergoing mitosis, and they will be forming so many offsprings. And now these offsprings after multiplication are known as spermatogonia. Just using a different color pen. Spermatogonia. Right, children? That means after completing multiplication phase, this is done by cell division mitosis. Many offspring cells are there. Out of primordial germ cells, many have been formed, and now these are known as spermatogonia. After spermatogonia, the second stage would be growth phase there. Now, growth phase, that means something must be growing and increasing in size, right? So here it is quite understood that the spermatogonia, we will be taking one into consideration. Whatever is happening with one, it will be happening with all, right? But since we don't have that much of space, you just take one cell as an example and tell that how the things are proceeding further. So whatever is happening with one will be happening with others too, right, children? Here the spermatogonia will be, you can see that I have drawn slightly bigger structure. This bigger structure is characterizing that the spermatogonium is increased in size. That means it has undergone the growth phase, increased in size, and now you can no more call it spermatogonia. You will be calling it primary spermatocyte. Please mark this word site. Primary spermatocyte. We can understand now that okay, the grown up phase is primary spermatocyte, and what is the chromosomal status within? I have written here diploid, 2n. 2n is still diploid. That means till now whatever cell division was going on was mitosis, and after mitosis spermatogonia was formed, and spermatogonia increased in size due to the growth phase, and the diploid status is still maintained, but we will not be calling it spermatogonia anymore. We will be calling it primary spermatocyte. It's a very important stage there. You know why? Because after primary spermatocyte formation, the first meiotic division is taking place. First meiotic division, why I have used this word meiosis 1, because we know very well, you all have studied this in the at the level of class 11th, that meiosis is completed in two cycles, meiosis 1 and meiosis 2. So it's basically meiosis 1 where the chromosomal number is reduced to half, and whatever is the outcome of meiosis 1, it follows mitosis only in the second phase, thereby giving rise to two offsprings. I have already told you that if the result of meiosis 1 is two offsprings of haploid status, now they will be participating in meiosis 2 only, right? So but obviously whatever is the chromosome number of the parent will be the chromosome number of the offspring in meiosis 2, because it is just like mitosis. This is what you have to take care. So I have used the word meiosis 1. Primary spermatocyte undergoes meiosis 1 and forms two daughter cells. But you can see that here the ploidy of the cell is changed. Here the diploid status is converted into a haploid. This is single N, right? So chromosome number is already reduced to half there. Okay, children. Then this stage, now since meiosis 1 has already occurred, so you cannot call it primary spermatocyte anymore. Now this is something superior. You will be calling it secondary spermatocyte. After meiosis 1, the stage that you have is secondary spermatocyte. Secondary spermatocyte will undergo meiosis 2. So since the parent cell has single N, obviously the offspring would also be having single N only. And once the meiosis 2 cycle is completed, the structures which are formed are known as spermatid. Spermatid. Right, children? So, primary spermatocyte undergoes meiosis 1, chromosome number reduced to half, primary becomes secondary spermatocyte, and then meiosis 2 is completed. So, each of the two cells would be giving rise to two more cells. It's just like mitosis, and four daughter cells are the result, and they are haploid. As of now, this is a spherical structure, dear. Please understand, this is a spherical structure, so you will be calling it spermatid. But in the very next stage, you must be watching that there is a head and a tail, right? So the head and the tail differentiation, the moment this is done, at that time you call it spermatozoa, right, children? Spherical body with the haploid status, spermatid, but a flagellated body with head and tail, spermatozoa. You people might pose a question that spermatozoa are immotile within the testis. Very true. These sperms are immotile within the testis. If they go further, if they are pushed further in the seminiferous tubule, they are pushed by the mucosal secretions, right? And the contraction and relaxation of testis due to tunica albuginea, middle layer. This is the propelling force so that sperms can be thrusted into the rate testis area. But tail and head, you cannot ignore the existence of a head and a tail, and when this structure is attained, at that time you call it spermatozoa. I hope I have made myself clear. Again, I am letting you know, you will be starting with the primordial germ cell. Mitotic divisions will be multiplying. First phase is multiplication phase. So mitotic divisions will be leading to increase in the number, and the structure will be known as spermatogonia. Then this will be entering the growth phase. This is the benefit of writing the phases at the left side. Why? Because you yourself understand what would be happening here. So since you know that the things are entering growth phase, obviously the size of the cell would be increasing, and now you will call it primary spermatocyte. Thereafter, since the maturation phase is there, obviously there should be some change in the ploidy of the chromosome. Since it is the maturation phase, meiosis 1, straight away mark it on board. Meiosis 1, thereby reducing the chromosome number to half, and the stage would be known as secondary spermatocyte. And meiosis 2 is just like mitosis, so whatever you have in as secondary spermatocyte, it will be producing two more offsprings in meiosis 2. Spherical bodies are there with the haploid status, you will call them spermatid. And thereafter, in the very next stage, the head and the tail is formed, and then you will be calling it spermatozoa. Right, children? Now I tell you the main difference. Right in the beginning, I used the two terms spermatocytogenesis. So that means the point till when spermatocytes are formed. Now you know very well that spermatocytes are formed till secondary spermatocyte. This is the phase which is spermatocytogenesis, and thereafter you see only two steps are there. One is the formation of spermatid and the formation of spermatozoa. So the formation of spermatozoa from spermatid is known as spermiogenesis. Formation of a motile sperm or flagellated sperm from a spherical body having a distinct head and a tail. This process is known as spermiogenesis. Now, what exactly is the change in the spermatid? Spermatid is a spherical body here, and you are saying that it converts into a head and a tails like structure, right? This is spermatid and this is spermatozoa, right? You need to understand that within the spermatid, the cell bodies, cell organelles like Golgi bodies. We know that Golgi bodies are they have a specific function of secretion of lysing enzymes. So here you have to link up the thing that since we already know that the head of the sperm has acrosome that contains the enzyme hyaluronidase. This is the content which is a change. Spermatid develops acrosome at the top of the head, and this acrosome is containing the enzyme lysing enzyme hyaluronidase. And who has done this? The Golgi apparatus which is present inside the spermatid. This has made the acrosomal body at the top. Another change that occurs when the spermatid converts into spermatozoa, at that time you need that there should be a very, very, very motile tail. I mean, at least it should be developed. There should be some precursor to it, right? This is due to the assembly of all mitochondria. You know, already you have drawn the structure of sperm. You know that many mitochondria are there present in the middle piece. So, assembly of mitochondria as the middle piece, making a mitochondrial sheath. This will be providing much of energy to this sperm, energy factory, right here. And another thing, I'm just using a different color to tell you people that when you talk about the centrioles here, we always know that one is proximal at the beginning of the middle piece and one is distal at the end of the middle piece. And this one, the distal one, is actually responsible for drawing those axial filaments which combine together to form the tail, right here. So I hope this much is clear to you. Just revise it. I know that you need to see this chart lot many times, seeing all the subheadings, all the phases that are supposed to be marked. And if you have any queries, kindly message me. We will be proceeding further with oogenesis in the next video.